With the help of this test problem, let's try to once again understand domain and range of reciprocal function or rational function. Now, the critical characteristics of these functions is that they have vertical and horizontal asymptotes. Now, asymptotes are the lines where the function is trying to reach but is never there. So, its domain is restricted in both. So its domain is also restricted and range is also restricted, right? So let's figure out what is the domain and range of the given function. So one criteria is that you can sketch it and get your answer. The second is you can analyze it, right? So let's first analyze it, okay? So what is going to be my vertical asymptote? So from here, vertical asymptote is when denominator is 0, right? So we say, well, denominator equals to 0. Now our denominator is minus x plus 1. Let's equate to 0. And this is 0 when x is equals to 1. So this is 0 at x equals to 1. So we know vertical asymptote is x equals to 1, and therefore in our domain we can now write domain is set of all real numbers but x is not equal to 1. So we get our domain in this fashion, right? So that is probably the best way and the fastest way of getting the domain of rational functions in any kind of situation. Now, how about the range? For range, we have to analyze the horizontal asymptote. So for that, let's analyze horizontal asymptote. Now horizontal asymptote, we have to see if x is very, very large, that means approaching like infinity, right? In calculator, you can put a large value like something like 1000, right? Just put a number 1000 and calculate. That helps. So it could be x approaching large number in positive direction or in negative. So you can plug in minus 1000 and calculate. But how do I analyze it? Without calculator. If x is very large, then it is 2 over a large number. Do you understand? So if it is 2 over large number, it will be 0. Do you see that? 2 divided by, let's say, 1000 will be 0.002. So that 0.00 makes it very, very small as compared to 3. It only says that it is that much away from 3. That is, it's trying to reach 3, but slightly away. That is what horizontal asymptote is all about. And therefore, we say horizontal asymptote is y equals to 3. And since we know horizontal asymptote is y equals to 3, this particular number, now we know our range. We say range is equals to y belongs to real numbers, but y is not equal to 3, as the function is trying to reach there. That is how it is. I hope you now appreciate the beauty of this, right? So, but if you want to sketch, you can do that also, right? So sketch it. Now x is equals to 1 is your vertical asymptote. Just sketch it like this, correct? Second, this is your horizontal asymptote, plus 3. So just sketch it. So that is now our function, where this point is 3 for us and this point is 1 for us. And these are our vertical asymptotes and horizontal asymptotes. Vertical asymptote being x equals to 1 and horizontal being y equals to 3. Do you see? That is my y-axis and x-axis. Now why am I sketching it? Because I'm going to add 2 more questions here. That is, I want you to write increasing and decreasing interval. For this function, right? And I want you to really sketch this function to get this answer. The trick is there because as you can see here, it is minus x, so it gets reflected. So normal 1 over x would have been on these quadrants, right? But this time, since it is minus, it gets reflected. Do you see that? Correct? So So I would like you to sketch this function and then find the characteristics of these functions, right? You can also figure out what are its intercepts, right? So I would like you to extend this question and now from domain and range, find the characteristics, find what are its intercepts, and during which region is it increasing or decreasing? Is it forever increasing or forever decreasing? Correct? Answer these questions. That will help you to understand these kinds of functions better. Thank you and all the best.